Hi everyone, and welcome to this video. Thank you for watching the previous videos. In this video, what we are going to do is we're going to look into how to load a dataset in R and how to work with the basic how to do the basic work around with the dataset. So the first step is actually getting a dataset into the R environment. So in order to do that, we can actually use a code to load a dataset, or if your dataset is a CSV or an Excel file, so we can just read it from directly with from the environment tab. So I'm going to load a CSV file, which is like a form of Excel file stored in comma separated variable format, which helps in storing a file with much less size. So here, if you want to import that, so in my desktop I have the file and it's named direct marketing. So here, so this is how the file loads. First of all, it automatically assigns the name of the file as direct marketing. Now, since this is how our data would be stored and we'll be calling the code many times, it actually makes sense to name it much easy way. So we can name it as DM, and the encoding is done automatic, row names automatic. They figured out that this is a comma separated variable, so CSV, so the comma and then decimal points are on decimals. Then the last thing is they are going to take in the strings, that is the non-numeric data. We want them to come as factors. So there are two ways it can come. So either it can come as, say, just not factors, which means that these are proper nouns, names of people or names of places. But here, if a quick glimpse shows that these are basically grouping variables. Like in age, we have old, middle, young, gender, male, female. So the way to the easiest way to load this is actually term strings as factors and then press import. So as we can see, the data is loaded. It says that there are 1000 entries, which basically means 1000 observations or 1000 rows, and 10 variables, which means 10 columns. And here we see a glimpse of the data. So basically, let me give an example, explanation of the data we have here. This is actually a supermarket data where these are like monthly spending of each customer. So they have taken 1000 customers and they have collected this data. So the first one is actually the age, where we have three groups of people: old, middle, and young. Then we have gender, which is male and female. They had a dichotomous gender relationship here. Then we have whether the customer owns home or not. So own means that the customer lives in an owned home, and rent means the customer lives in a rented home. Then married is basically where the customer is whether they are married or single. Here single includes widowed, divorced, or separated, all of them in the single area, whereas married is where someone is married. Now for location, this says that for whether the customer comes from a faraway location or a close location. The salary is the monthly salary of that customer in Bangladeshi taka. And then we have the number of children the customer has, the history of the customer, which basically means here that how frequently the customer comes. High frequency means that the customer comes more than 3 to 4 times a month in the store. Low frequency means he just comes only once a store or even less than one time, and 2 to 3 times is medium frequency. So as you can see, there are some missing values here. And finally, you have the catalogs, which gives you an idea of how many number of catalogs these customers receive. Catalog here means marketing messages. So either they have been given catalogs in their home or have been sent over in the emails, like email marketing or SMS marketing. So this counts like each customer who have gotten how many of these catalogs. And finally, the last one is actually the spending amount, which is like the amount spent by the customer in a month's time in the store. So this is the data. Now and we will be looking into we have looked into how we have loaded the data, but now let's quickly look into what we can do with the data. So in R, one very useful thing to work with the data is the summary function, and we can just put in the name of the data set. So when you run this here, we see a detailed summary, a summary of the whole, like all the 10 variables we have. So the age variable, we see that since this is a grouping variable, so it has been divided into middle, old, and young. And so mostly middle people, some old people, and some young people. Now Then there is a gender variable. So the gender variable shows the um, the gender variable shows half of them are male and half of them are female. The own home is equally divided. Married is equally divided. Location, most people come from close, some from far away. Salary, since it's a numeric variable, it gives very the 5 number or the 6 number summary of the salary, which is like the minimum salary, maximum salary, first quartile, which means basically 25% of the people from like have salaries below 30,000. Third quartile, which means 25% of the people have salaries above 75,000. The median is 53,000, mean is 56,000, which means this is a very well balanced salary distribution. Now, I'll skip children for now. History, we can see that there is 303 NAs. NA in R means missing value. So this shows me that out of 1,000 people, almost 30% people's history was not available. Number of catalogs, again 5 number summary, and amount spent, again 5 number summary. So this is actually a very simple code to get a very quick overview of a data set. Now, besides that, I would like to show you one important thing here is children. Though children is termed as numbers 1, 2, 3, 4, 5, 6, but the thing is it cannot be coded as number because there is nothing called 0.934 children. So children should be a grouping number where although it is stored as numbers, but we should use 1 as a group, 2 as a group, 3 as a group, because we want to see how many customers have 1 children, how many customers have 2 children, how many customers have 3 children. So in order to fix that, what we can do is, first of all, we create, so before we fix the children, let me show you something. This is how we can find out certain spaces of the data. So suppose I want to find out which is the third row. We want to see the third row of the data set. The way to see the third row would be dm 3 comma blank. So this gives me the third row of the data set. So here the syntax is like this: dm, then the third bracket, and then the first part is row number, comma, column number. So if, say, for example, I want to find out what is the, say, I want to find out row 8, column 5. The way to find out is dm, row 8, column 5. So that's close or far, and the value is close. So similarly, if I want to find the 100th row and say columns 5 to 10, so the way to do it is dm the 100th row and then columns 5 to 10, which is shown by the colon here. So here it shows the 100th row, the location is far, the salary is this, children number is 2, history is high, catalog is 18. So suppose I want to see how much am I, like, what is the 150th customer looking like in my data set. Here, the 115th customer is a young female who rents her home, is single, comes from far away, has a salary of only 11,400, has 3 children, and she receives a catalog of 12 catalogs, and the spending is very low. This means she might be actually not unmarried, but she might be a single mom. So yeah, that's how you can find out the rows. Now if I want to find out the column, if I want to find out what the 5th column looks like for the whole data set, what I can do is keep it blank, the row, which means they're going to select all rows. The blank here means that you're going to select all rows or all columns, and then choose the 10th column, or say the 5th column. If I run this, so this shows the location column, all the location data. There is another easy way to look at columns, is actually like this. We put in a $sign, and when you put in a $sign, R asks us to choose which column name I want to see. So say I want to see the column history. So just pressing enter there, and then command enter or control enter shows me the history column. This is handy because say I want to find out what is the average spending. So it would be mean and then dm of amount spent. Here, this gives me the average spending. If I want to find out the standard deviation of the salaries of the people, of the customers, so the standard deviation short code is SD, and then we can have dm salary here. So the standard deviation is quite high here. Okay, now The next thing we can do is, our target was like, fixing the children variable, because children should not be numeric but should be a factor. So in R, there are three types of way of storing data. One is numeric, which is numbers. Then there is just text, string. And then there is factors. Factors is like middle, old, young, own, rent, married, single. So grouping variables. So here the children would be grouping variable, where the one group would be single children, another would be two children, another group would be three children. So the way to fix it is, we start with DM and we choose the children variable, and now we assign it. So basically the idea is, actually let me go back here. So first of all, we choose the children column, and then we convert it into a factor. So the way to convert it into a factor, this is numeric, so it will be as dot factor. So now this output would basically give me children's as factors, where factor would be 1, 2, 3. One factor means one children, two factor means two children, and three means three children. So now I want to store this data in the children column of DM. The way to store is assign this to DM of children. So the children variable or children column of DM gets assigned this factor converted version of DM children. So basically what I'm doing is I'm taking the children column, converting into factor, and then putting it back to the children column and replacing the previous data with the new data, which is the factor format. So when I run this, nothing comes out because it happens on the dataset itself. But now if I run the summary function again on DM here, now you see children is formed as factors because there are 0 children, which is 462 customers with 0 children, 267 customers with 1 children, 146 customers with 2 children, and 125 customers with 3 children. So that's a very quick overview of loading a data frame and what we can do with the data frame. Another thing that I'll show you is sometimes we can also create new variables in a data frame. So suppose we have spending amount and also number of catalogs. So one thing we can do is we can do a calculation of what is the spending amount of a customer per catalog. So we can divide the spending amount divided by the catalogs. The way to do so is basically we create a new variable, which is DM, and let's name the new variable, say, spending per catalog. So when R will not find that there is something called spending per catalog in DM, it will understand that I'm telling it to create a new variable. Now the way to create this variable would be, we take in DM amount spent and then we divide it by DM catalogs. So when I do that and run, so we have, as you can see, from 10 variables it has become 11 variables. If you open our DM, you'll see that yes, we have created a new column called spending per catalog, which is based on spending amount divided by number of catalogs. And now if we again go back and check the summary of DM, we'll see that there is a new summary. So the average spending per catalog is $75, 75 taka. The mean is 86 taka. The maximum spending per catalog is 473 and the minimum is 633. So this is how we can do some quick calculations on the data set. Also, if you want, we can also do some quick scatter plots, so to see any relationship between two data, there, like whether there is a relationship between two data or not. The way to do so is we start with plot and then we give say we want to see the relationship between salary and amount spent. We know that as people earn more, people spend more. So let's say amount spent and DM salary. In the right hand side you see that there is amount spent and there is salary, and this is the distribution of the points there. So we can see that there is actually a relationship that the more the salary, the more the amount spent. If you want to change the axis and we want the salary in the x-axis, it would be plot DM here. So we see that the more the salary, the more the amount spent. So this is like a very quick overview of what we can do with data sets in R. In detail, we can do way more stuff, and hopefully in my future videos or in my training sessions, you can actually find them there. So hope this you find useful. Again, any comments or any suggestions would be appreciated. Thank you so much.